They also ask us for the effects that the transformations had on the domain, the range, the equation of any asymptotes, and any intercepts that we had. Okay, so let's talk about that. So my original domain, what was that? What was my original domain? The black curve there. It's everything, right? Okay. So x is an element of real numbers. The range?
Y is greater than 0 and y is an element of natural numbers?
Nope. Real numbers.
Real numbers, okay.
Ah, come on.
That means I was wrong.
So y has to be bigger than 0. Why can't it be exactly 0?
Because there's an asymptote.
There's an asymptote there, right? There's nothing that you can raise this to the power of 2. Sorry, there's nothing that you can raise 3 to the power of and get a negative number or even 0. Okay, they also ask for equations of any asymptotes. So what was the original asymptote equation? Where is the line that black curve does not touch? Y equals 0. Okay? And any intercepts that I had originally. This might help here. What's the original y-intercept? 1, right? When x is 0, that'll tell you the y-intercept. Okay? So I have an x-intercept at, oh sorry, not an x-intercept, a y-intercept at 0, 1. Do I have any x-intercepts?
I thought it was 0, 2.
No, you don't have any x.
I thought it was 0, 2.
Yeah, because it doesn't cross. No, it's 0, 1.
Oh, that's for the original.
For the original, yeah. Okay, now let's see what effects the transformations had on those parameters, or not those parameters, those characteristics. Okay, so this is the transformed function. Any effect on the domain? Any effect on the domain? Okay, none. Range? No effect. Those are the same, thankfully. Asymptote? What would change the asymptote? What kind of transformation would change it? A vertical translation, right? The intercept?
0, 2.
That's probably different, right? How'd you get 0, 2?
What do you mean? Because it was doubled. The y values were doubled, so then it's the original equation.
Mm-hmm.
The y value of 1 is doubled to 2.
But when y is 2, x is 4.
Oh man, it's the
Wait,
same.
what are we talking about? It's not the same. Oh, we're talking about the second.
Yeah,
last
the green
equation.
one. The green one, yeah.
Oh,
Do you guys know how to find these?
you have to find when
When x is 0, it'll cross the y-axis if it exists, right? So I take my transformed equation and I make x 0, right? Whenever x is 0, that's when it's going to cross the y-axis. Okay, you can just see that graphically. If I go to 0 on this green curve, as soon as I hit 0 for x, that's when I hit the y-axis, right? So we make x 0, oops, y equals 2 times 3 to the negative 4, which is 2 times 1 over 3 to the 4. Can somebody evaluate that for me? What's 3 to the 4? 1 over 243 times 2, so 2 over 243, I think.
81.
It's 81? Oh, so it's 2 over 81. Okay. Is that right? I think that's right. 3 to the 4 is 81? Okay. So there's our y-intercept. Okay. So 0 and 2 over 81. You could put it as a decimal approximation if you wanted, but... Good? And then any x-intercepts that came up now? No. Okay. Those don't change. What's up? For what? Just no effect. That's what I mean. What effect did the transformation have on the domain? Nothing. It's still the same. The range, nothing. It's still the same. Okay?